Hello, here we are again. We have Pre-Calc Lesson 59, Advanced Logarithmic Problems, and the color of the White House is white. So I'm going to just jump into a couple examples. If we were to solve this, the log base 4 of x plus 2 equals the log base 4 of 5, we remember that if we have two logs of the same base, then their arguments are equal. So I can say x plus 2 equals 5, so x is 3. Okay, here's another example, slight review. If we have the log base 4 of x plus 5 equals 2, I don't have two logarithms, but I can rewrite it in exponential form. I can say 4 squared is x plus 5, so 16 is x plus 5, so x is, not 9, 11. Okay, so those are just some quick review problems. Okay, now let's talk about more advanced logarithmic problems. Advanced log problems, we want to use our log rules that you have memorized by now, our product, our quotient, and our power rules. Okay, so let's just do an example to show you that. If we have 3 times the log base 10 of x equals the log base 10 of 16 minus the log base 10 of 2. So I have my power rule here. I can rewrite this as the log base 10 of x cubed. And I have my quotient rule here. This becomes the log base 10 of 16 divided by 2, which is 8. Now, I have two logs of the same base. That means their arguments are equal. So x cubed equals 8. So x is 2. Okay, I just am using all of my different log properties. Let's do another example. If I have the log base 7 of x plus 1 plus the log base 7 of x minus 5 equals 1, two logs of the same base being added, I multiply them, so I get x plus 7 times x minus 5 equals 1. Now I'm going to rewrite it in exponential form. 7 to the 1 equals x plus 1 times x minus 5. I need to FOIL these out, so I get 7 equals x squared minus 5x plus x minus 5. So now I'm going to bring my 7 over. I get x squared minus 4x minus 12 equals 0. And I see if I can factor this, which I can. X minus 6 times x plus 2 equals 0. So x is 6 and negative 2. Okay, now I have to look and see if I plug in 6 to both of these, does it work? 6 plus 1 is 7, 6 minus 5 is 1. Yes, it works. If I plug in negative 2, I get negative 2 plus 1, which is negative 1. And I can't take the log of a negative number, so negative 2 is an extraneous solution. So x just equals 6. Okay? So remember, you can only take the log of a positive number. Okay, let's do another example. Two log base 3 of x minus the log base 3 of x minus 2 equals 2. I'm going to rewrite this as the log base cubed of x squared over x minus 2 equals 2. I just combined two steps into one. So I move this 2 up as a power, and then they were minused, so I could divide them. And rewrite it in exponential form. So I get 3 squared is x squared over x minus 2. So 9 is x squared over x minus 2. I can cross multiply. So 9 times x minus 2 is x squared. So 9x minus 18 is x squared. Bring all my terms over, so I'll get x squared minus 9x plus 18 is 0, and I'm going to factor this into x minus 6 times x minus 3 is 0, so x is 6 or 3, and do both of those terms work? They do. Okay? Now, let's talk about the color of the White House is white. That's a duh statement, okay? Now, the reason we say that we have a duh statement, okay, is if we have something like this, 42 raised to the log base 42 of 5, right? If we can read this statement as 42 raised to the power of 42, or what raised to the power of 42 must be in order to get 5, right? So 42 raised to what power gives me 42 raised to the power of 5. That's what this is saying, and so it's 5. Okay, same thing if we have e. If I have e raised to the natural log of 5, this gives me 5. Okay, I can also see it, this is one way, this is another way. If I had the log base e of e to the 6, this just gives me 6. Okay, so, and this is all because logarithm means exponent. We've talked about this before. Okay, so let's do a couple examples. If we have 9 to the log base 3 of 5, okay, I can rewrite this as 3 squared to the log base 3 of 5, which if we have a power raised to a power, we multiply it, so I get 3 to the 2 log base 3 of 5. Now I can use my powers of exponents. I can rewrite this as the log base 3 of 5 squared. So this just gives me 5 squared, which is 25. Okay, let's do another. If we have 10 to the 4 log base 10 of root 3, okay, we can rewrite this using our exponential power as 10 to the log base 10 of root 3 to the 4th. So this just gives me root 3 to the 4th, which is root 3 squared squared. Root 3 squared is 3 squared, which gives me 9. Okay, let's try this one. 3 to the log base 3 of 4 plus the log base 3 of 5. If I have two logs of the same base being added, I can rewrite it as the log base 3 of 4 times 5. And that just gives me the log base 3 of 3 to the 4 base 5, right? 3 to the log base 3 of 4 times 5 gives me 4 times 5, or 20. Okay, or what about log base 5 of 25? I can rewrite this as the log base 5 of 5 squared, which just gives me 2. Okay? So, properties of logs. I hope you have memorized them by now. They are super, super, super important. Excuse me. That is all for our example today.